Alrighty, well, hello everybody. I'm going to let some folks trickle in here. We've just kicked this off. If you are here, you are at the Retrotec blower door webinar here. So this is just a good, quick class for beginners, or maybe if you haven't tested in a while, you have one coming up. It's just a good way to kind of brush up on some of your skills. So we're just going to cover some of the basics and then cover some new things too that we have going on as well. Kind of some bonus features that have been added to our new gauge that can kind of help you out through some of your tests. So we will kind of dive in with setting up the house and everything like that, and then we'll transition over to the lab here and actually cover all the hardware that's involved with the blower door, how everything should be set up, some of my tips for things, and things such as that. And so it looks like we've got a good crowd here. So my name's Sam Myers. If we've never met before, I'm our in-house building scientist and one of our trainers. And online with us here is Noah Lawrence. Noah is new to our team. He is going to be taking over a lot of tech support roles. So if you ever call in tech support, good chance you'll be talking to Noah later on. So Noah, thanks for joining with us today. And the chat box and Q&A should be active. If one isn't, the other should be. So if you have any questions as we get into this, feel free to ask away there. We'll stop about halfway for questions, and we'll stop again at the end and have some more discussion if any more questions come up. And Noah will be there monitoring the chat box and the Q&A box and answering questions along the way. So we'll go ahead and get everything kicked off here. So if you've never been in here before, this is my own air tightness testing lab. This was a product of the COVID pandemic when we weren't traveling. So this is a 10 by 10 by, it's an 8 by 8 by 10 foot tall chamber that we can basically mimic any type of air tightness test on, from residential to commercial buildings to multifamily. We can even have this simulate an HVAC system. There's a separate chamber at the top. We can allow that to be our duct system, or it can be a vented attic or an encapsulated attic. So we have all kinds of videos on our YouTube channel where we really kind of get into the weeds of different type of test scenarios on this chamber and explain the process. But that is what you see here. So we're going to do the live demo on this today. Just makes it really easy for virtual training. So one thing that's pretty new to blower door testing is the new DM32X manometer. We came out with this earlier this year, and it has kind of changed some of the process. So this is what I'll be using today, is one of these new gauges, and kind of walk through some of the features and how to get the readings that you need whenever you run a test. We won't dive through all of this gauge today and all the features. We've got more videos online and other webinars that do that. But as far as actually running the blower door test and how to find some information in it, we will cover that. So before you set up a blower door system, and say you get to a house to do a test, before you really start unpacking everything, you want to make sure that the house is going to be set up properly. So you really want to have all of the doors and windows, exterior doors and windows closed, windows latched. You want to have interior doors open, and skip through this here. Some of these videos that I'll show can be found on the gauge itself. But let's get through to where we are going to cut through here. Here we go. So yeah, we want to make sure all the windows are shut. We want this house to be kind of like it is in its natural condition. So we want the envelope to be completely closed. Windows shut and latched, exterior doors shut and locked. Interior doors we want to have open, all of them. Doors kind of behave like dampers, and what we want to do when we're running a blower door test is, if we're testing a residential structure, it's going to be a 50 Pascal pressure differential. So that can be positive or negative, and all that determines on which way the fan is facing. So if I am inside of the house now, and if this is my exterior door here, if this side of the fan is facing me, then that means the air is going to be blowing, exhausting air to the outside, depressurizing the house. Most standards will let you test in either direction. It's up to you. I usually do a depressurization test when I can, because throughout the building envelope, we have bath dampers, kitchen exhaust dampers, and things like that. If I were to flip this fan around and pressurize the house, all those dampers could fly open. That's leakage that I really don't want to count. So if I flip the fan around and have it to depressurize like this, with the inlet side facing me as I'm inside the house, then it will pull those dampers closed and not pop them open. If you get into some of the passive house standards and things like that, or some commercial standards, sometimes they'll require you to test in both directions and take an average of the two. But if you're a HERS rater, or if you're just doing tests for weatherization or an energy audit or something like that, usually just a single direction test is all you'll need for that. So in order to get that 50 Pascal pressure uniformity, we want to make sure that the entire house is getting under that 50 Pascal pressure differential. So we want to open all the doors to make sure that each room is going to achieve that same pressure target. So we don't want to close off any part of the building to give us a funky reading. Fireplace dampers, we want to make sure those are shut. That's leakage that we don't want to count to. Any combustion appliances we want to set to off or pilot. And the only thing that we want manipulating pressure in the building envelope is the blower door fan. So if there's any exhaust fans running, sorry, I'm jumping around here. If there's any exhaust fans running, like a bath fan or kitchen exhaust, we want to make sure those are powered off. Again, we want that blower door to be the only thing that's manipulating pressure. Same thing for dryers. We don't want those running either because they exhaust air to the outside. So we want to make sure those are cut off. HVAC system, we don't want that fan blowing. We want to make sure that that fan's going to be off. Same thing for ventilation systems. If the HVAC system has some kind of whole house ventilation built into it, whether if it's an air cycler with a damper connected to the outside on the return side, or if it's an ERV or a ventilating dehumidifier, we want to make sure that that's not going to kick on during the test because it will kind of screw with our blower door number a little bit. So we want to always make sure and see if that thing's on a timer or what's going to trigger it, make sure it's not going to come on while we do that. So we want to have full control of the house as far as pressure goes. And I want to touch back too on the point of the pressurization versus depressurization, basically which way we have the fan facing. I mentioned earlier that I like to pressure or depressurize whenever I can, but there are a couple of scenarios where that's not such a great idea. And this is primarily in existing homes that have been around for a bit. Probably the most important one is if you have any kind of asbestos insulation in the attic, like vermiculite. Zonolite was the brand of vermiculite insulation that was popular for a very long time. That is the one scenario where we at Retrotec recommend not running a blower door test at all. Even if you pressurize the building, you can disturb that vermiculite insulation and it can settle back down into the living space. Now, some people argue, well, okay, 50 Pascal pressure differential is the same as a 20-mile-an-hour wind hitting all six sides of the building. So a building can experience that on its own. Well, it's our opinion that, if you're going to do that, you could possibly be held liable. It's really just to kind of keep the tester safe, as well as the occupants too. We don't want that we don't want them to breathe that stuff in. So kind of two things there. So that's really the only reason, the only scenario where we recommend not running the test. So if you're testing any older homes where that kind of insulation was used, it's good to always kind of pop up in the attic and see what's up there. Sometimes insulators in the past have blown fiberglass on top of it. So sometimes it's a good idea to maybe see if there's another layer underneath. So we've seen that happen quite a bit too. But just a good thing to keep an eye out for. But another reason or another scenario where I don't recommend depressurizing is maybe if you have a bunch of ashes in the fireplace. If it hasn't been cleaned out, if that's not something you're going to do, you really don't want to depressurize the house and then pull those ashes into the living room. Lots of people have done that. I have done that, and I haven't done it again. It's one of those things where I had to learn the hard way because it will make the whole house smell like a campfire. So always check that. If there's a wood burning fireplace, see what's going on with that before you start manipulating pressure across the envelope. You don't want to pull that stuff in. It can make a really big mess. Another is if you have mold growth along the building envelope, we really don't want to disturb those mold spores and pull them inside. So that's another case where we say, okay, maybe pressurizing the house is a better alternative here. So that way we're kind of pushing that stuff out instead of pulling it in. So just some things to be mindful of as you go into older homes that are having some indoor air quality issues or things like that. It's always good to, better be safe than sorry. So let's say we've gone through the house, we've done all of our checks, everything looks good. We have all the combustion appliances set to pilots. We have all of our fans off. Windows and doors are all set up the way they need to be. So now we're going to start unpacking some equipment and piecing it together. So the first thing that I always start with is the frame. It has 4 sides that snaps together to form a rectangle. Each corner is marked with a number, so you just match the numbers up. 1 to 1, 2 to 2, 3 to 3, 4 to 4. And if we want to break it down, this is all you have to do is just snap it apart like that. We have 3 size frames. We have a standard and extra large. Some houses today have massive front doors. And then we have a small window frame too. So if you do any passive house testing and you want to include the leakage to the doors, you can set a duct tester fan up in a window. So 3 frame options there. And the corners just snap together, make sure the numbers are matching up, make sure all the handles are on the same side. You want to make sure that rubber seal along the edge is continuous along the outside, and you're good to go. That's about as easy as we know how to make it, is just matching the numbers on the corners and snapping it into place. So there's a couple different ways you can install the cloth. I like to just lay it across the floor like this. Some people like to drape it over the front door vertically and set the frame into it that way. Both ways are correct. It's just a personal preference. I think it's easier just to spread it out if you have the floor space to do so. And once you have your frame fit to your door, you basically just lie it into the cloth and then wrap it like a present. There's little Velcro tabs where it just kind of wraps in like that and fits into place. And start from the bottom and work your way up, and then pull that top down and Velcro it into place there. And then that's about it. Open the door back up and then pop it back in. One thing that I didn't talk about earlier, I guess, is expanding that frame out. Once you put that frame together, if it's a small rectangle, if you loosen all the cam levers up, you just set it into the door, spread it out horizontally, then spread it out vertically, and then cinch it down into place. And that's about it. It's one of those things where once you do it the first time, it's pretty simple. And sometimes whenever I put my frame in the door at first, I like to do a loose fit because that cloth is going to take up a little bit of room. So once you have it completely finished here, it's good just to kind of go back and make sure everything is nice and snug and fit into the doorway. Then you have these cam levers here that you'll flip up, and it'll just snug that frame into the doorway a lot better. And then you have 2 additional crossbars too that we give you. One goes across the bottom right above the hole where the fan will be. So the fan will actually hang from that. And then there's a second one that goes up about eye level, usually just above where that window is. That just gives you some better stability in the doorway. The last thing we want is for this thing to go flying off anywhere. And it has 2 cam levers as well that you'll flip to lock it into place. Give it a good shake, make sure it's not going to go anywhere. So one thing that's new, at least over the past couple of years, is we've changed our cloth. If you have an older cloth or if you use a blower door from another manufacturer, one thing that you would have to do is there's a tiny hole down here at the bottom of the cloth, and you'll take a red tube, pull it through, and then toss it out to the side. The way that a blower door works is actually, let's talk about this. We'll talk about the smart cloth in a minute. Let's talk a little bit more about this configuration. So here, even on this newer cloth, we still put them here. This is that little patch I was talking about. It has a hole that goes through to the outside. But with your blower door kit, what you get is, there's 3 main components. There's the framing, the cloth, there's the fan, and the manometer. This manometer is what we refer to as a 2-channel manometer. So if I take this off and bring it closer to you, I can just disconnect it for now. So you'll see that on this gauge, there are 4 ports that go across here. Each one's a different color. So we call this a 2-channel manometer because it's basically 2 manometers built into one housing. So one side, we call this channel A, we call this side channel B. Channel A has this red port. So for blower door testing, you're going to connect a tube to that. That's going to connect to the outdoors. This is a differential manometer. It's kind of similar to what like an HVAC contractor would use to measure static pressure, except this is a much more higher resolution because again, we're reading in terms of pascals, which is a very small unit of pressure. So it has to be extremely accurate. So in order for this to take a reading, you're basically just reading pressure in one place compared to another. So the system knows when it gets to 50 pascals, because when the fan ramps up and creates that pressure difference, it's reading what the pressure is outside. That's how it knows when it gets there to 50. The other side has a yellow port that you'll use on a blower door test that you'll connect to the yellow fan. So this color coordinating setup here is about the easiest way we know how to make it. So the red tube to the red cloth, the yellow tube to the yellow fan. And so what that's reading is fan pressure. And so the way that a blower door can give you what the leakage is of a building is if we know the hole size of the inlet side of the fan, which we do, there's different ways we can set up the hole size from completely open down to a small hole. The manometer knows what each hole size is at each configuration. So if we know fan pressure, which we do, we're collecting it here, and we know the hole size, we can calculate flow in CFM. And that's essentially what this manometer is doing. It's reading pressure, then doing the math to give you the flow. Back in the day, we didn't have that. So we would just have to take all of these pressure readings and then do the math longhand to figure it out. Long time ago, blower door tests were pretty complex processes. Now it's straightforward and easy. Once you get a few of these down, it takes about 15 minutes to do a test. Once you get a couple under your belt and you feel comfortable with it. But that's essentially how it works. This is really the brain of the whole thing. This is taking all the readings, doing all the calculations, and giving you your output. So I'm going to put this back and hook everything back up. This bundle of tubing that you see here, make sure you're seeing this. Yeah. So it comes in a red netting. There's the red tube and the yellow tube that I was telling you about that connects to the cloth and then to the fan. There's also a data cable, looks like a Cat5 cable. This allows the gauge to power the fan. So when you open up the gauge app on the DM32X, we want to set the house to 50 pascals. You can do that without having to touch the fan at all. It just automatically runs it and controls the fan. So it does that through this data cable. And then there's also a charger cable on here too. Our fans come with a USB port built in. So maybe if you forgot to charge your gauge overnight, if you get there and it's dead, you're not dead in the water, you can just plug the gauge up to the fan, you have power, and you can still run your tests. So that's just kind of a backup thing that we give you guys for our systems there. So I'll go ahead and connect this back up. Data cable goes at the top, red to the red port, yellow to the yellow. And there's a little loop here at the top. This Velcro's on there. There's a belt clip on the back of the gauge. And it just slides on there like so. And I like to make sure that all my tubing's just kind of neat and out of the way. You don't want tubes dangling in front of the fan, blowing and moving around, because sometimes that can kind of play with your number. You really want to have all of your tubing kind of in a steady place where it's not going to be knocked around too much. You definitely don't want to step on tubes. If you step on a tube, for example, like a red tube or something like that, it can really jump that pressure up and down. So you want to make sure that it's going to be just kind of neatly rolled up and tucked out of the way. The fan itself, you can see on this side, there's this lip here. The back side has that exact same lip. And so on this cloth is just an elastic hole. And so the way I do it is just set the fan into the hole, pull it around that lip, and then you've got a Velcro strap here that you pull the fan up to this crossbar and just kind of let it hang there like that. And that's it. As far as how that fan installs, I'll bring it up a little bit closer here just so you can see what those tubing connections look like on the fan side. So if you want to plug your gauge in to a power source, you can right here. You've got your data cable that plugs in here. And then that yellow tube plugs into the fan here to read your fan pressure. There you go. Now you can see it. So all that's on this one side here. Your power plugs into the wall on this side. Noah, do we have any questions in the box at this point?
I've had a good one that I've been answering are there any differences in testing with a single family residential and say an apartment building or a large building? So the science is the same. There are some differences in the setup, but the sciences that we're going over and the setup that applies here with the single fan is pretty transferable to other testing scenarios, and we have other webinars on that. One thing, if you're testing in an apartment building that I wasn't quite sure of, Sam, with the smart cloth, would be opening up that hallway or whatever you're going to test into be enough, or would you want to bypass the smart cloth and take a longer tube to outside?
Yeah, I always, here, let me show you here. One thing I didn't show you is where this tube plugs up to the cloth. So there's a tube that comes out of the cloth here. That's where your red tube plugs into. And so on the other side of the smart cloth, it's just reading on the other side of the cloth. So this tube here has a T and splits. One end goes and terminates there with a T on the end, and then the other end comes here with a T on the end. And so what Noah's asking, if we're testing an apartment building, is that sufficient, or should we reference someplace else? The answer is usually we should reference someplace else, especially if we're testing units on an upper floor. Say if we have like a 3-story building, we want to reference each apartment from the same spot at the bottom floor. So that's when having a longer roll of that red tubing is going to help. So the first thing that you're going to want to do at an apartment like that, if you're just doing a compartmentalized test on the apartment itself up on a higher floor, go ahead, have some doors open, be able to run that red tubing up through a stairwell or up through an elevator shaft to be able to give you that reference to the bottom floor, because things like stack effect will play there where it'll give you some kind of fluctuating readings from unit to unit. And so having that steady place to reference is important there. So your standards are going to point that out to you. Yeah, it's a good question, Noah.
Yep, I think that's all we have for questions so far.
Okay, great. So let me go back to, let's see, we've got the system set up here. So let's talk about what we're going to do to run a test. So it's important to know how to navigate your gauge. I'm going to pull up, I have a program that I use to mirror my gauge on the screen, and hopefully, Noah, is that showing up? Can you guys see that?
Yep.
Okay, great. Cool. So when you power on the gauge, this is the home screen that you see, and there are 3 apps at the bottom. This one is to launch the gauge to actually run a blower door test and generate a reading. If it hasn't been fired up yet, it just takes a couple seconds. There we go. All of this is built on an Android platform. So if you've already used an Android device before, like a phone or a tablet, you're kind of halfway there. So it still has these same navigation buttons at the bottom. So I can hit the circle to go back home. This middle one is rCloud. We're not going to dive into this today, but essentially what this is an app we've had for quite a while. The legacy DM32 that we've had for the past 10 years had a Wi-Fi antenna in it, so you could pair devices with it to automatically generate reports and automatically run tests, geolocate where you are, get outdoor weather data and things like that. But connecting a device to the DM32, sometimes connectivity issues were a problem, especially if you were long distances away. So our solution to that was just build the app into the next gauge. So we did that. So now you can generate reports. save tests, have everything there in a library on your gauge without having to have a phone or a computer or a laptop. Here we'll go ahead and go back to our gauge app. And so this is how you want things to look when you launch it. Pascals, you're reading for channel A, CFM for channel B, and then your fan here underneath. But sometimes maybe if you open it fresh out of the box, it may not be on pascals, it may be on inches of water. The way we built this menu on the DM32X is if you want to change something, just tap that part of the screen. We wanted to remove the need to go and hunt through a settings menu. So pretty much anything that you see here that is not output the way you want it output, click it. So I can just click channel A here, go back to pascals. Channel B, you have plenty of options here. You can output pressure or flow. There's options for each. So for example, flow, I mean, we have metric, standard, flow normalized by area. There's all these things that are in here. Air changes per hour for code, a lot of times that's required. And say you use ACH a lot and you don't want to have to hunt through this to find it every time, we put a favorites button. So if you just heart it, it'll be there at the top of the list for you every single time. Just like CFM, I use that one all the time, so I want it at the top. So you have that there too, just so you don't have to hunt for it every time. And then just click the one you need. Same thing for your fan. Sometimes people will use the same gauge to do blower door tests and duct leakage tests. Just realized my camera is still on that other one here. Let me flip back over so you're not just staring at a blank wall. There we go. So again, I'm using a model 6000. This is a high output fan, but if I just click model number, there's all the options that I can choose. So if I use the model 6000 all the time, I can choose that. If you guys are mainly doing residential tests, whether if you're a HERS rater or doing energy audits for residential properties, the model 5000 is going to be perfect for that. You just really don't need all the extra power in most cases that the 6000 has. So if that's the one you use, again, we put favorites there, so it'll always be at the top. 450 is something that you don't use, you can take it out. So that way, all the fans that you use all the time will be there. You don't have to go hunt for them every time. So all those are in there. The flow box, we still have the whole flow function. If you want to make your own exhaust fan flow meter, all the TEC fans are in there too. So plenty of options to choose from. You just want to always make sure you're going to be on the right fan. So we have it in bright yellow letters there to show you which one's selected, as well as which range is selected too. You'll see the picture of the fan here. You can tap on it to change the range. One of the most important things here is always making sure your gauge matches your fan. And you can see the different pictures of the ranges here. So open, which means there's nothing on it. You just have everything off and it's wide open. If I go back to this fan here, I can pull off, we call this the B8 plate, because after A, we get B, and it has 8 holes in it. So that's how we landed at that name. If you pull that off, if you wanted to run the fan wide open, there's 4 bungees in here that are attached to the motor mounts around the edge. So you can just pop those off and pull this ring A off to get it wide open. Snap it back in, pop it back in place to put it back on. And there's magnets on the B8 plate. And so it just sticks on like so. So we like this scenario because there's no moving parts to break off. Magnets and bungees are pretty much it. Those are going to last you a very long time without breaking. And if you're smaller than, having the B8 range has all these open. But if you're going down to like B4, like you see here, or B2, you have a tighter house that's going to require that. Make sure you have those exact holes open that are in the picture, because that's how the fan was calibrated when it came out of the factory. This is one of the biggest mistakes that I see from people in the field, from people posting their blower door tests online. We love it when you guys do that. Well, we love to see what you're up to, but this is always the most common mistake that I see is B4 through B1 set up incorrectly. You can't just pick whatever 2 holes you want. Just make sure you're matching the picture, and then you're good to go. A common question that we get is, okay, well, say I'm all set up and I'm ready to go. Where do I start? What range do I start with? My answer to that is usually going to be, I'm going to say ring A. It's easy to start with. You just pop it off. You're there. If it's a house I've never tested at before, I feel like most code-built houses are going to fall in this somewhere. And the cool thing about the new DM32X is for each range on each fan, you can see the flow ranges here. So ring A on this fan is going to be from about 1300 to just under 5,000 CFM. It's kind of a similar wide range for the Model 5000 too, but that's a good amount of flow to play around with there. And if you're running ring A like that and you cannot get to 50 pascals, then that's when you know that you need to open it up more. It needs more airflow going through. So stop the test, pop this ring A off, reset your fan to open, and then you should be able to hopefully get to 50. If not, then you have a really leaky house, is what the answer is going to be to that. We have a lot of people that do 2-fan tests on big leaky houses. That happens sometimes, but it's not often. And the other way around, say if I had it to ring A, I could get to 50 pascals, but I get like 2 dashes on channel B. That's telling me that I need to choke it down some more. Those fan blades aren't spinning fast enough to generate enough pressure inside the fan shell for the manometer to take a reading. So then we would put the B8 plate on, go the next range down, and then match our gauge accordingly. So after A is going to be B8, and we'll make it look like that. The nice thing about this cloth is there's pockets on it. So as I need to take plugs out, I can just drop them in there. That way I don't have stuff scattered all over the floor to get lost or stepped on. You can just kind of keep everything all together. But yeah, those are some of the most common questions that we get. A, where to start? B, like, okay, where do I go if I can't reach 50, or where do I go if I can reach 50, but I'm not getting a reading? That's just the gauge telling you that you need to change your range to either go up or down. And we actually had videos on that built into the gauge that you don't need internet to access. They're just built right in. Well, we'll get to that at the end. But we'll go back to A here. Okay, so let's say I'm all set up here. I've got pascals on channel A. I've got CFM on channel B. I've got the right fan selected. I have the range that I'm going to start with. Before I actually run the fan to take a reading, there's one other step that I have to do called taking the baseline reading. So I mentioned before that the way that a blower door system works is that manometer there on channel A is responsible for reading the outside conditions compared to the inside conditions. Well, we have some things at play that can mess with that a little bit. We have stack effect that I mentioned before, and we also have wind. I live here on the coast in North Carolina, and we get some pretty blustery days. And when we're talking about a low pressure test, like a 50 pascal test, a lot of wind can really throw that around. So what the baseline reading does is you're essentially leaving the fan covered like so, or you can use the shower cap cover that comes with it. Either one works fine. And you're just letting that gauge collect data. See what it's doing outside. See what those natural pressure differentials are for that day and that moment. Windier days, I'll let it run for a little bit longer just to collect more data. And then basically what that's going to do is remove that reading from the equation. It's like if you're going to weigh something, you want to zero out the scale first. It's kind of what we're doing here with wind and stack effect. So the way that I'm going to do that is we have this button here called bias. Bias pressure, baseline reading, they're interchangeable terms. They mean the same thing. So this is how you take your baseline reading, is by click this bias button. And it's going to pull up this graph. And then there's a record button down here, like you're about to start filming. you can go ahead and click that and it'll start collecting data. We're indoors, so we're not really going to see a whole lot of pressure differential, but as I was telling you before, if you step on a tube, it can really mess with the reading. So I can actually take this red tube here and squeeze it a little bit, and you can see what it's doing to that graph. So that's why it's really important you don't step on this. But also, if I had a windy day, that's kind of what it would look like. You would see that graph go up and down like that. So you would see it go into the positive and into the negative. And you can see that our average is changing a little bit. So if I squeeze harder, to make more wind, well, I guess it's going in both directions, but you kind of get the gist of it there. That's what a windier day is going to look like. So if it's a calm day, there's not a whole lot going on outside. 30 seconds is good. On a windy day, like if we had it kind of looking like what that graph is looking like there when I was messing with the red tube, then I would let it run longer, maybe a minute or two, just to collect more data, just to get a better idea of what's happening outside, so we can cancel that stuff out as best we can from our blower door number. And when we're ready to stop, we can just hit stop, and it'll ask me if I want to save it. Yes. Okay. And I can just hit this arrow to go back, and now I can see what my baseline is here underneath channel A when I go back. Okay, so I've collected that. I'm ready to run the tests. I can now pull off my plate here because let's just start with ring A and see what we get. I can go to this button here that says set pressure. Couple of things. If this is a house that's existing that I have never tested before and that has some indoor air quality issues going on and there's some wonky things happening, I may not want to ramp up to 50 immediately. Maybe I want to go to 25 and then walk around and see if I, can smell, wetness or something like that I don't want to pull in more. Or maybe make sure I'm not interacting with a fireplace or something like that. So maybe I'll just go to 25. We have these hotkeys over here to the side that are the most common pressure targets in air tightness testing. There we go. So you can see right when I hit 25, it kicks the fan on. I don't know if you guys can hear it or not, but it's running. And I kind of overshot a little bit, and it'll work its way down. But we're really not getting much of a reading. It's actually overshooting it because that's about as low as it can go. So if I've reached that target or even gone past that target and I'm not getting a flow, it's telling me that this ring A is too much. I need to start choking it down. So I'll just go ahead and hit stop, click on my fan, and I'll go to B4 and skip down because we're testing a small chamber. And again, I can see these flow ranges that this fan can meet. And for this small chamber, I really don't expect it to be over 1,000 CFM. So I'm thinking in this window here, is going to be our best bet where it's going to be. So I'll take my plate, and again, I'll make it match exactly. I see those 4 holes on each side open. So that's what I'm going to open up and then drop each plug into the pocket. And pop it back on there like so. So my fan, again, is matching the gauge. So I can go back to set pressure here. I'll go to 50 pascals. There we go. So it's met that 50 Pascal pressure target. Now I'm getting a flow on channel B here. So about 400 CFM, 412, 413 CFM is what we're getting. So if I'm going to report that in CFM, that's how I would do it. If I wanted to report it in ACH 50, all I would have to do is just tap on channel B, choose ACH, and notice when I do that, it brings down some more information here in this ribbon in the middle. So this is for 50,000 cubic feet. Say Okay, maybe this is a larger building. Say maybe this was like 75. Set back. So it shrunk that number some. Or if I went the other way, maybe it's 25,000 cubic feet. Set. And it brings it up close to 1. So yeah, larger buildings are easier to pass with ACH 50. That's usually what it comes down to. But yeah, you always want to make sure that's going to be correct. And you want to have a good way to measure what that volume is. Whether if you're measuring it on site, or I can actually, if you press this hold button, it holds the reading, then you can stop the fan and not lose your data. So if you're with a homeowner and you want to talk about what this means without a fan blowing to talk over, you can do that. That's what the hold button does there. And then you can still go in and change things around if you need to represent it in different ways. But always make sure that the volume that's in there is the volume that you are needing to reference for that house, and that you have a good way to measure it, whether if you're able to get it from the plans. If it's new construction, that's really nice. It's a lot easier to do if you have plans to go by. But a lot of times we don't always have that if we're in weatherization or if we're doing energy audits on existing homes. Laser distance measurer like this is going to be, your best friend there to go around and take some quick measurements, especially if we have vaulted ceilings, maybe some conditioned or encapsulated attics that we need to take into account. The laser distance measure is nice to be able to capture all that and make sure that we have the correct volume to test to. So that's how we can get our readings in both CFM 50 and ACH 50. So Noah, did we have any other questions come in? It's a good place to stop. Yeah.
So one of them is, are we posting this recording of the webinar? Are we able to get this to some of the participants?
Yeah, we're recording it now, and we'll have it posted probably early next week.
Awesome. And then another one is, if we have the DM32, should we upgrade to the DM32X?
That's up to you. If the DM32, if it's working great for you, if it's doing everything it needs to do, then yeah, hang on to it. We still service them. We still calibrate them. We'll continue to repair them as long as we have parts in-house. But if the DM32X is something that's you're gonna get a lot more value out of, then sure, upgrade. That's going to be up to you. They're totally different gauges. It's the DM32 has been out it came out in, I think, winter of 2012. So it's been out for a little over 10 years. And the DM32X is the result of all this technology that's been available that we've been wanting to use.
I personally wish
that's a personal question.
Yeah, I wish I had started with the X, because I think those support videos being on board the gauge is a game changer when you're first starting out, or if you're not running tests all that often. Just having something right there as a reminder real quick, watch a 2-minute video and you're refreshed. I think that's really worth it.
There's some physical attributes too, like the screen is a capacitive touch screen, kind of like your iPhone. It actually uses the exact same glass. It's the newest Gorilla Glass, so it's super durable. We actually, when we were testing it, we did some military spec drop tests on it at different angles, at different heights, on different surfaces. And the way we got that screen to break was by throwing it out a second-story window at the office onto a gravel parking lot. So it passed all the military tests, but then we did some more extreme stuff to see what would actually break it. And the new Gorilla Glass is nice. It's actually in the iPhones too. I've had this phone for over a year and bravely have been going without a case and dropping it all the time, and it still hasn't cracked. So we're using the same stuff in this gauge, and it's really durable. So that's been a feature request we've gotten from DM32 users in the past, especially those who are pretty rough on their gear. We want this stuff to be able to help to hold up over time, because we understand that it's going into construction sites. Guys are doing tests that are short on time, so things happen. So we're trying to make things as durable as possible. But yeah, like Noah mentioned, here I can go ahead and stop this test here and back out. And like I mentioned before, like if you're familiar with Android, I can hit the square button to close out apps or cycle through other apps that I've had open. But if I go back to the home screen, this R with the folder is our resources app. So all of the equipment that we manufacture, so the DM32X, our blower doors, our duct testers, the flow box, and so on, we have them for pressure pans and the powered flow hood for the duct tester as well. But say if I have a blower door, you can access the full manual for it in here. It's a PDF that you can zoom in on. This is a 1080p OLED display on this gauge, so it comes up really crisp. It's easy to read text on it. If you've bought Retrotec gear in the past, you've probably noticed that in the case, it came with a laminated hard copy one-pager quick guide of how to set up your blower door or your duct tester and get the reading that you need. So we've updated those for the new gauge, and you can kind of see that here. So if I walk over to the gauge and actually zoom on the screen, you can navigate through it, scroll down. Talks about pressurization test, depressurization tests, generating your reading, and everything like that. So so there's quick guides there. And then like Noah mentioned too, we have videos. So kind of those little clips that I showed you before that had the intros that I was trying to skip over because I still haven't edited those out for presentations yet. It's broken down into different sections. So like if you're trying to find a YouTube video on how to like do something, one of the most annoying things is finding this long video and trying to find the section that matters to you. We broke it up into sections to avoid that. So setting up the house, kind of that similar video that I showed you before, setting up the frame, setting up the cloth, hooking up the fan and the gauge, setting up the gauge to make sure that everything is input correctly to give you the readings that you need and the right metrics, taking your baseline reading. So for example, if I click on that, it uses that landscape function, gives you that little intro, make sure you clicked on the right video, and then just, yeah, it's me diving right into it, going through a blower door test section by section, and showing you how to do each part of it. So again, these videos on the DM32X, you do not have to have an internet connection to access these. They're built in locally on the device. If you are connected to the internet, the library gets bigger. You can access some more stuff from our YouTube videos that goes deeper into the weeds. So that's just kind of another bonus that we threw in there too. And while you're in this app, we have this little hamburger menu at the top. If you click on it, there's some more stuff that we're going to be adding in, some different calculators, like if you do have a large building, how many fans do I need to do this, or a stack effect calculator just to see how much stack effect is pushing and pulling on that building. So we're going to add some more calculators and worksheets as well, likely going to be in this section if they don't have their own apps. But that's another one of the nice things about the DM32X is it has over-the-air updates. So if I swipe up, yeah, there's a bunch of prototype stuff in here that we're going to be working on. But there's this app in here called the R Store. It looks like a gauge in a shopping cart. That's where you go to update everything. So if we come up with bug fixes or new features or something like that to any of the apps that we make for this gauge, as long as you're connected to Wi-Fi, you connect to Wi-Fi at your home or your office, just like you would your phone or your computer. And then you can go and update everything as you need to. This one's all up to date. But in the DM32, you had to download a configurator from our website, then physically plug the gauge into a computer to update it that way. Those days are gone with this gauge anyway. So as far as keeping things up to speed, it's pretty nice that way, just to be able to automatically update over the air like that. But that's kind of the quick and dirty on it, on running a blower door test with the new DM32X and the smart cloth. Those are kind of the two big changes to the process anyway that we've added in over the past couple of years. And there's going to continue to be some upgrades and new features and new apps available for this gauge. One thing that we're working on is Hike Micro, the thermal imaging company. We've gotten their permission to use their app, so we can actually pair the gauge with a camera and you can save thermal images straight onto the gauge. And eventually, once we upgrade our cloud, that's, you can add thermal images to your R cloud reports and add notes on what those mean, things like that. So those are things that we're currently working on. And there's going to be some more cool stuff that this gauge is going to be able to do as we come up with new apps and software updates and things like that. So hopefully that kind of covers all of that. Noah, did we have any more pop in?
So how often would you say you need to update the firmware?
I would check it like once a month. If there's a major update, we'll post it or we'll send out an email. But I would just check it occasionally. I mean, you just pull up that RStore app and just check and see if there's an update, and that's really all you have to do. Some other new things for diagnostics, we have this mini probe that came out. I came up with this idea last year, made the first batch, taught our production team, what materials and processes that we need. Basically, what you do is you can use this to find leaks in the building envelope with your gauge or with an additional gauge. So it's a 1/16 of an inch diameter. So you can connect it to a tube, get up underneath shoe molding, get up underneath baseboards, access wall cavities without having to drill a hole. It's small enough that you can usually find some kind of nook or cranny to get it into. So for example, if I'm depressurizing this house to negative 50 pascals, if I'm reading 34 pascals positive there, I got something going on in that wall or floor assembly. So it's just a quick, easy way to find pressure differentials to help you lead to where some problem areas are in the building envelope. So that's the mini probe that's now available. So yeah, super small, so you can access stuff like that, do zonal pressure diagnostics and things like that. ASIN Flow Finder is a powered flow hood we've had for a while. There's now the ASIN MK2 Plus, so it has an upgrade for the user interface. Takes measurements faster. It reads a little bit higher flows. So if you've been looking at these, instead of having this red arrow to tell you which way it's blowing, it actually tells you if it's a supply or an exhaust. So these are actually nice too, to be able to quantify air leaks. So for example, if you're depressurizing a house and you're getting 1,000 CFM50, if you put this over a can light and you get 10, well, that's 10 out of that 1,000, and the other can lights are probably 10 as well. So it can read flows down to, I think, like 7 CFM. So you can put it over, pretty much any kind of termination like you would a pressure pan, but instead of just getting a pressure differential, that actually tells you what the flow is through that leak at 50 pascals with your blower doors. So pretty cool if you've never seen that before. It's just been upgraded just now over the past couple of weeks. So first time this tool has gotten a significant update like that in a while. Better battery life too. Noah and I both mentioned our YouTube channel. If you haven't checked it out, it's packed full of stuff. I have a series that I need to start back up again called Technical Tuesdays. I think there's about 50 videos in there right now, just on very specific testing tips and things like that. So if you haven't checked that out, feel free to dig through. And if you have questions, reach out to us. You can get me at sam@retrotec.com, or you can get Noah or Lee or Tim over at support@retrotec.com. We're always happy to help you out. And before we log off, I'll ask one more time if we have any questions.
Yeah, so one of them, are we going to continue to provide firmware updates for the DM32s, or how soon do we need to upgrade?
Yeah, the latest DM32 firmware upgrade that you'll find in the configurator is going to be the last one that there's going to be. There's really no bugs or anything in there that we found. So that's the last firmware update for the DM32 that there will be. So yeah, you can go on our website and or you can open up the configurator to see if there's an update available.
And then there's one that goes a little bit beyond 101, but I like it. So could we re-explain the bias pressure for blower door testing versus the 2 bias pressures needed for room integrity testing for fire suppression systems?
Oh, wow. So that's another webinar that we plan on having later down the road. It's a completely different application for residential house testing for energy audits and indoor air quality and things like that. So for the baseline for the house, all we're doing is just trying to weed out wind. and stack effect from the outside. For the two pressure, Noah, do you want to try to tackle that one?
Yeah, so for the two pressure, you're taking biases in kind of the testing scenario that you've set the room up in, and in what the hold time will be like for whatever that system you're using for fire suppression is. So if you've got mechanical systems that are going to be on during hold time, but not on during your test, then you'll have two potentially slightly different bias pressures, is my understanding.
Yeah. So what a enclosure integrity test is, a lot of people on the call probably aren't familiar with that. It's an application for blower doors where you can test a room to see how capable that room will be to handle clean agent fire suppression, which is like a foam that comes out at a high pressure. So if it's not vented properly, you could really do some damage to the room or to the building. But this is really for like server rooms or control rooms that has stuff like that can't get wet. So it has this foam that fills the room up, and that foam needs to stay at a certain height for a certain amount of time. So like you usually see the standard, it has to have a retention time at a certain height for 10 minutes. So we have a totally separate set of software that does all this. The testing procedure is completely different than what we do for just testing for to see what a air leakage number is for a house. Yeah, that's something that our founder Colin Genge developed back in the 80s.
Yep. So I think that's the end of our questions.
Okay. Yeah, great. Well, we'll try to do some of these a little more often. I know it's been a while. We did a duct testing one last time. If there's a webinar that you were looking for on a topic that we don't have, or a video that we don't have that doesn't answer your question, let me know and I'll add it to the list. We're going to be getting back into video mode here pretty soon once conference season gets over. We're not traveling so much. So yeah, we want to be able to quickly provide you guys with resources to answer your questions that you can always refer to. And if we don't have that, let us know. And we can definitely put that together for you. So we'll let that be the end. And again, as you guys get more into this, if you need some further help or if you have any questions, reach out to us. This is what we're here for. We're happy to help you out. And hopefully this was helpful for you guys. And again, we will have this on our YouTube channel here in the next few days. So we'll go ahead and call it a day. And that's a wrap. And thank you guys for joining. And we'll see you again next time.